Welcome to the fastest way to learn data structures and algorithms with this premium revision material. Today we are mastering LeetCode 380, the Insert Delete GetRandom O of 1 challenge. This is a classic design problem frequently asked in interviews at top tech giants like Google, Amazon, and Microsoft. Let us look at the problem statement. Our task is to design a data structure that supports 3 main operations, all an average O of 1 time complexity. First, insert a value if it is not already present. Second, remove a value if it exists. And third, get random, which should return a random element from the set where every element has an equal probability of being chosen. Think of the challenge here. A hash map gives us O of 1 insertion and deletion, but it does not support O of 1 random access. An array or list gives us O of 1 random access using an index, but deleting an element from the middle takes O of n time because we have to shift elements. To achieve O of 1 for everything, we need to combine these two. Imagine a perfectly organized library. You have a physical shelf where books are placed in sequence, that is our array. You also have a digital catalog where every book title maps to its exact slot number on the shelf, that is our hash map. When you want to add a book, you put it in the next empty slot and update the catalog. When you want a random book, you just pick a random slot number. But what happens when you remove a book from the middle? It leaves a gap. To keep the shelf compact and avoid shifting everything, we use our golden rule. The swap and pop strategy. Instead of shifting, we take the very last book on the shelf, move it into the gap, and update the catalog with its new location. Then, we simply remove the last slot. This keeps everything in O of 1. Now, let us dive into the dry run. This is the most important part. Look at the screen. We have an empty list on the left, and an empty hash map on the right. Notice the caption box at the bottom tracking our steps. First, we call insert 10. 10 is not in our set, so we add it to the end of our list at index 0. We also update our map, storing 10 as the key and 0 as its index. Look at the map content updating now. Next, we call insert 20. Again, 20 is new, so we append it to the list at index 1. In our map, we store 20 with index 1. The structure is growing perfectly. Now, let us add one more. Insert 30. 30 goes to the end of the list at index 2, and we map 30 to index 2 in our catalog. Our set now contains 10, 20, and 30. Here comes the tricky part. Remove 10. Notice that 10 is at index 0, not at the end of the list. To remove it in O of 1, we look at the last element, which is 30 at index 2. Wait, look at the highlight. We swap 10 with 30. Physically, we move 30 into the first slot at index 0. Now, we must update our catalog. In the hash map, 30 now points to index 0. Finally, we remove 10 from the map and pop it from the end of the list. The gap is filled, the shelf is compact, and we did it all in O of 1 time. Finally, let us call getRandom. Our algorithm picks a random index, either 0 or 1. Let us say it picks index 1. We look at our list and return 20. Every element has exactly the same chance of being picked. Now that we have walked through the logic visually, let us see how this translates into our Python code. We define a class called randomizedSet. In the init method, we initialize self.nums as an empty list and self.pos as an empty dictionary. In the insert method, we first check if the value is already in our position map. If it is, we return false. Otherwise, we store the current length of the list as its index in the map, and then append the value to our list. The remove method is where the magic happens. We find the index of the value we want to remove, and also identify the last element in our list. We then perform the swap, placing the last element into the target index in both the list and the map. Finally, we pop the last element from the list and remove the original value from our map. For getRandom, we simply use random.choice to pick an element from our list in O of 1 time. Looking at the complexity, the time complexity is average O of 1 for all 3 operations. This is possible because hash map lookups and array appends or pops are all constant time. The space complexity is O of n, where n is the number of elements we store in our data structure. And that is the Insert Delete GetRandom challenge mastered. Save this video for your next interview revision, and follow for more deep dive DSA explainers. Send this to your coding partner to help them level up.